In this video, we'll find the least common multiple of two or more numbers and the greatest common factor of those numbers. The least common multiple, or LCM, of two or more numbers is the smallest number that is a multiple of both. The LCM is divisible by both. To find the least common multiple of 3 and 5, examine the multiples of each number. For 3, we see 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39. For 5, we see 5, 10, 15, 20, 25, 30, 35, 40. I've circled the numbers that appear on both lists, 15 and 30. 15 is less than 30, so it's the least common multiple of 3 and 5. We can also use prime factorization to find the least common multiple. To find the least common multiple of two or more natural numbers using their prime factorizations, first, list the prime factorization of each number, writing repeat factors in exponential notation. Second, write the prime factorization of the least common multiple by including the prime factors appearing in each number. If a prime factor appears in more than one number, pick the one with the higher exponent. Third, write the resulting expression in standard notation. So as an example, we'll find the least common multiple of 12 and 40. So first we do the prime factorization of the original numbers. 12 is 2 squared times 3, and 40 is 2 cubed times 5. Then we'll find the prime factorization of the least common multiple. There is a 2 factor in each of these, so we want the one that has the higher exponent, which is the 2 cubed. Then we'll take the 3 from 12 and the 5 from 40. So the prime factorization of the least common multiple of 12 and 40 is 2 cubed times 3 times 5. And when we multiply that out to get the standard form, we get 120. The greatest common factor, or GCF, of two or more numbers is the largest number by which all the numbers can be divided. To find the greatest common factor of two or more numbers, we first list the prime factorization of each number, writing repeat factors in exponential notation, just like we did with the least common multiples. Then we list the prime factorization of the greatest common factor by including each prime factor appearing in every number, not each number. The prime factor has to appear in all of the numbers. If a prime factor appears in more than one number, use the factor with the smallest exponent. If there are no common factors, the greatest common factor is 1. Then write the resulting expression in standard notation. So for example, we want to find the greatest common factor of 15, 30, and 45. So we list the prime factors of each number. 15 is 3 times 5, 30 is 2 times 3 times 5, and 45 is 3 squared times 5. Now we write the prime factorization of the greatest common factor. Well, we see that each of these numbers has a 3 and a 5. This one has a 2, but the other two don't have a 2, so we can't include the 2. This one has 2 3s, but the other two only have 1 3, so we can only use 1 3. So the greatest common factor is 3 times 5, since both of those factors appear in each number. Finally, we write that in standard form. 3 times 5 is 15. So the greatest common factor of 15, 30, and 45 is 15.